Chapter 11. We have seen that some of the most brilliant inspirations of godlike intellects, or some of the most pestilential emanations from infected minds, have been attempts to account for the virtual changelessness of the stars. Above all other data of astronomy, that virtual changelessness of position stands out as a crucial circumstance in my own mind. To account for constellations that have not changed in 2,000 years, astronomers say that they conceive of inconceivable distances. We shall have expressions of our own upon the virtually changeless positions of the stars, but there will be difficulties for us if the astronomer ever have found that some stars move around or with other stars. I shall take up the story of Professor Struve and the companion of Procyon, with more detail for the sake of some more light upon refinement, exactness, accuracy in astronomy, and for the sake of belittling, or for the sake of sneering, or anything else that anybody may choose to call it. Professor Struve's announcement of his discovery of the companion of Procyon is published in Monthly Notices 33-430 that upon the 19th of March 1873 Struve had discovered the companion of Procyon, Procyon, having compared it micrometrically, having tested his observations with three determinations of possible position angle, three measures of distance, and three additional determinations of position angle, finding all in excellent agreement. No optical illusion could be possible, it is said, because another astronomer, Lindman, had seen the object. Technically, Struve publishes a table of his own observations, sidereal time, distances, position angles from March 19 to April 2nd, 1873, after which his observations had to be discontinued until the following year. In Monthly Notices 34-355 are published the resumed observations. Struve says that Ors would not accept the discovery unless in the year that had elapsed, the companion, I can't get this book to sit there, the companion had shown increase in position consistent with theory. Struve writes, this increase has really shown itself in the most remarkable manner. Therefore, he considers it decisively established that the object of his observations was the object of Auer's calculations. He says that Saraski of Moscow had seen the companion without being warned of the place where it was to be looked for. However, see back some chapters. It may be said that nevertheless other stars have companions that do move as they should move. Later we shall consider this subject, thinking that it may be the lights have been seen to change position near some stars, but that never has a star revolved around another star as to fit paleoastronomic theory it should. I take for a basis of analogy that never has one sat in a park and watched a tree revolve around one, but that given, damn, why is it something wrong with my light? I'll blame it on that. Where is that? But that given the affliction or the endowment of an astronomer, illusion of such a revolution one may have. We sit in a park, we notice a tree. Wherever we get the notion, we do have the notion that the tree is moved. Then, farther along, we notice another tree, and as an indication of our vivid imagination or something else, we think it is the same tree farther along. After that, we pick out tree after tree farther along, and convinced that it is the same tree, of course conclude that the thing is revolving around us. Exactness and refinement develop, we compute the elements of its orbit. We close our eyes and predict where the tree will be when next we look, and there, by the same process of selection and identification, it is where it should be. And if we have something of almost everybody's mania for speed, we make that damn thing spin around with such velocity that we, too, reel in a chaos of very much unsettled botanic conventions. There is nothing far-fetched in this analogy except the factor of velocity. Goldschmidt did announce that there were half a dozen faint points of light around Sirius, and it was Dahl's suspicion that Clark had arbitrarily picked out one of them. It is our expression that all around Sirius, at various distances from Sirius, faint points of light were seen, and that at first, even for the first 16 years, astronomers were not thoroughly hypnotized and would not pick out the especial point of light that they should have picked out, so that there was nothing like agreement between the calculated and the observed orbit. Besides the irreconcilable observations noted by Flammarion, see the Intel OBS 1-482 for others. Then came standardized seeing. So in the Observatory 20-73 is published a set of observations in the year 1896 upon the companion of Sirius, placing it exactly where it should be. Nevertheless, under this set of observations is published another set so different that the editor asks, does this mean that there are two companions? Dark companions require a little more eliminative treatment. So the variable nebula then and do dark nebula revolve around light nebula. For instances of variable nebula, see MEMS RAS 49-214, Comptes Rendus 59-637, monthly notices 38-104. It may be said that they are not of the Algol type. Neither is Algol, we have shown. According to the compulsions of data, our idea is that the stars that seem to be fixed in position are fixed in position. So now proper motion is as irreconcilable to us as relative motions. As to proper motion, the situation is this. The stars that were cataloged 2,000 years ago have virtually not changed, or if there be refinement in modern astronomy, have changed no more than a little more nearly exact charting would account for. But in astronomic theory, the stars are said to be thought of as flying apart at unthinkable velocity. So then, evidence of changed positions of the stars is welcome to astronomers. As to well-known constellations, it cannot be said that there has been change. So, with several exceptions, proper motion is attributed to the stars that are not well known. The result is an amusing trap. Great proper motion is said to indicate relative nearness to the Earth. Of the 25 stars of supposed greatest proper motion, all but 2 are faintest of stars. So these 23 are said to be nearest this Earth. But when astronomers take the relative parallax of a star by reference to a fainter star, they agree that the fainter star, because fainter, is farther away. So one time faintness associates with nearness and then conveniences change, and faintness associates with fairness, and the whole subject so associates with humorousness that if we're not going to be serious at all in these expressions of ours, we had better pass on. Observatory, March 1914. A group of 3 stars had... Damn! Hold on. A group of 3 stars that disappeared. If 3 stars disappeared at once, they were acted upon by something that affected all in common. Try to think of some one force that would not tear the seeable into visible rags, that could blot out 3 stars if they were trillions of miles apart. If they were close together, that ends the explanation that only because stars are trillions of miles apart have they, for at least 2,000 years, seemed to hold the same relative positions. In Agnes Clerk's system of the stars are cited many instances of stars that seem to be so closely related that it seems impossible to think that they are trillions or billions or millions of miles apart. Such formations as 7 aligned stars appearing to be strung out on a silvery filament. There are loops of stars in a cluster in Orgia, lines and arches in Opacus zigzag figures in Sagittarius as two stars that not only seem close together but that are colored alike. Miss Clerk expresses her feeling that they are close together. If these colors be inherent, it is difficult to believe that the stars distinguished by them are simply thrown together by perspective. As to figures in Sagittarius, fission, recent advances in astronomy cites an instance of 30 small stars in the form of a forked twig with dark rifts parallel. According to fission, probability is overwhelmingly against the three uncommon stars in the belt of Orion falling into a straight line by chance distribution, considering also that below this line is another of 5 faint stars parallel. There are dark lanes or rifts in the Milky Way that are like branches from main lanes or rifts, and the rifts sometimes have well-defined edges. In many regions where there are dark rifts, there are lines of stars that are roughly parallel. That it is not distances apart that have held the stars from changing relativity to one another, because there are hosts of indications that some stars are close together and are or have been affected in common by local formative forces. For a detailed comparison by J.E. Gore of stars of today with stars cataloged by Al-Sufi about 1,000 years ago, see Observatory Volume 23. The stars have not changed in position, but it does seem that there have been many changes in magnitude. Other changes: Pubs, Astro, Soc, Pacific, number 185, discovery of the 17th new star in one nebula, Andromeda. For lists of stars that have disappeared, see monthly notices 8-16. For lists of stars that have disappeared, see monthly notices 8-16, 10-18, 11-47, Sidereal Messengers 6-320, Journal BAA 14-255, Nebula that have disappeared, see American Journal of Science 2-33-436, Clerk System of the Stars, page 293, Nature 30-20. In the Sidereal Messenger 5-269, Professor Colbert writes that upon August 20th, 1886, an astronomer in Chicago saw for about a half an hour a small comet-like projection from the star Zeta in Cassiopeia. So, then changes have been seen at the distance of the stars. When the new star in Perseus appeared in February 1901, it was a point of light. Something went out from it, giving it in 6 months a diameter equal to half the apparent diameter of the moon. The appearance look structural. To say loosely that they were light effects, something like a halo, perhaps, is to ignore their complexity and duration of differences. According to Newcomb, who is occasionally quotable in our favor, these radiations were not mere light rays because they did not go out uniformly from the star, but moved out variously and nodded and curved. It was visible motion at the distance of Nova Persei. In monthly notices 58-334, Dr. Espin writes that upon the night of January 16, 1898, he saw something that looked like a cloud in Perseus. It could have been nothing in the atmosphere of this earth, nor anything far from the constellation, because he saw it again in Perseus upon January 24th. He writes that upon February 17th, Mr. Heath and Dr. Halm saw it like a cloud dimming and discoloring stars shining through it. At the meeting of the British Astronomical Association, February 23, 1898, Dr. Espin described this appearance and answered questions. It was not a nebula and was not like one. Whatever it was, it had the peculiar property of dimming and blotting out stars. This thing moved into Perseus and then moved away. Clerk, The System of the Stars, page 295, a nebula that changed position abruptly between the years 1833 and 1835 and then changed no more. According to Sir John Herschel, a star was central in this nebula when observed in 1827 and in 1833, but in August 1835, The star was upon the eastern side of the nebula. Excuse me. That it is not distance from this earth that has kept changes of position of the stars from being seen for 2,000 years, because occasional abrupt changes of position have been seen at the distance of the stars. That whether there be a shell-like revolving composition holding the stars in position, and in which the stars are openings admitting light from an existence external to the shell or not, all stars are about the same distance from this earth as they would be if this earth were stationary and central to such a shell revolving around it. According to the aberration forms of the stars. All stars at the pole of the ecliptic describe circles annually. Stars lower down describes ellipses that reduce more and more the farther down they are, until at the ecliptic they describe straight lines yearly. Suppose all the stars to be openings fixed in position relatively to one another in some interspacing substance. Conceive of a gyration to the whole aggregation and relatively to a central and stationary earth. Then, as seen from this earth, all would describe circles near the axis, ellipses lower down, and straight lines at the limit of transformation. If all were at the same distance from this earth, or if all were points in one gyrating concave formation, equidistant at all points from the central earth, all would have the same amplitude. All aberration forms of the stars, whether of brilliant or faint stars, whether circles or ellipses or straight lines, have the same amplitude, about 41 seconds of arc. If all stars are points of light emitted from externally, held fixed and apart in one shell-like composition that is opaque in some parts and translucent in some parts and perforated generally, the Gengishine, that we have indication that there is such a shell around our existence. The GEGNSCHEIN is a round patch of light in the sky. It seems to be reflected sunlight at night because it keeps position about opposite the sun's, the crux. Reflected sunlight, but reflecting from what? That the sky is a matrix in which the stars are openings, and that upon the inner concave surface of this celestial shell, the sun casts its light, even if the earth is between, no more blotted out in the middle by the intervening earth than often to be considerable degree is its light blotted out upon the moon during an eclipse of the moon, occupying no time in traveling the distance of the stars and back to this earth because the stars are near or because there is no velocity of light. Suppose the Gengishine could be a reflection of sunlight from anything at a distance less than the distance of the stars. It would have parallax against its background of stars. Observatory 17-47. The Gengishine has no parallax. At the meeting of the Royal Astronomical Society, January 11th, 1878, was read a paper by W.F. Denning. It was, by implications, one of the most exciting documents in history. The subject was suspected repetitions in meteor showers. Mr. Denning listed 22 radiants that lasted from 3 to 4 months each. In the year 1799, Humboldt noticed that the paths of meteors, when parts of one display, led back to one point of common origin, or one point from which all the meteors had radiated. This is the radiant point, or the radiant. When a radiant occurs under a constellation, the meteors are named relatively. In the extraordinary meteoric display of November 13th and 14th, 1833, there was a circumstance that was as extraordinary as the display itself. That, though this earth is supposed to rotate upon its axis, giving to the stars the appearance of revolving nightly and supposed to revolve around the sun, so affecting the seeming motions of the stars. These meteors of November 1833 began under the constellation Leo, and 6 hours later, though Leo had changed position in the sky, had changed with and seemed still coming from Leo. There was no parallax along the Great Base Line from Canada to Florida. Then, these meteors did come from Leo, or parallax, or absence of parallax is meaningless. The circumstance of precise position maintained under the moving constellation upon the night of November 13th and 14th, 1833 becomes insignificant relatively to Denning's data of such synchronization with a duration of months. When a radiant point remains under Leo or Lyra night after night, month after month, it is either that something is shifting without parallax in exact coincidence with a doubly shifting constellation, which is so unthinkable that Denning says, I cannot explain, or that the constellation is the radiant point, in which case maintenance of precise position under it is unthinkable if it be far away, that the stars are near. Think of a ship slowly sailing past a seacoast town, firing with smokeless powder, say, shells from its burst before quite reaching the town, and all explosion points are in line between the city and the ship, or are traceable to one such radiant. The bombardment continues. The ships move slowly. Still, all points of exploding shells are traceable to one point between the ship and the town. The bombardment goes on and goes on and goes on, and the ship is far from its first position. The point of exploding shells is still between the ship and the town. Wise men in the town say the shells are not coming from the ship. They say this because formerly they had said the shells could not come from the ship. They reason. Therefore, shells are not coming from this ship. They are asked how. Then the point of explosion could be so shit. They are asked how. Then the point of explosion could so shift exactly in line with the moving ship. If there be a W.F. Denning among them, he will say, I cannot explain. But the other wise men will be like Professor Moulton, for instance, in his books. Professor Moulton writes a great deal upon the subject of meteors, but he does not mention the meteors that for months at a time appear between observers and a shifting constellation. There are other considerations. The shells are heard to explode, so then they explode near the town. But there is something the matter with that smokeless powder aboard the ship. Very feeble projectile force, because also must the shells be exploding near the ship, or the radiant point would not have the same background as seen from different parts of the town. Then, in this town, inhabitants, provided they be not wise men, will conclude that if the explosion point is near the town and is also near the ship is near the town. Leo and Lyra and Andromeda are grosses that sail the sky and that bombard this earth, and that they are not far away. And some of us there may be who, instead of trying to speculate upon an unthinkable remoteness, will suffer a sensitiveness to proximity instead. Enter a new revolt against a black encompassment that glitters with a light beyond, and wonder what exists in a brilliant environment not far away, and a new anguish for hyperesthesia upon this earth, a suffocating consciousness of the pressure of the stars. The sickle of Leo, from which come the Leonids, gleams like a great question mark in the sky. The answer. But God knows what the answer to anything is. Perhaps it is that the stars are very close indeed.